A lot of developers are probably, wiping their brow saying, wow, at least we have some level of automation here that can help us with these, frankly, daunting and damn near impossible tasks of checking all of this code to make sure that it's robust from a security standpoint. Hey guys, welcome to Embedded Toolbox, the video interview series where you try to save the world by solving one engineering challenge at a time. And of course, a huge engineering challenge today has to do with security, which is a brave new world for a lot of developers in a lot of industries. And to help us broach that subject, we brought on Jim McElroy and Jay Thomas, both of LDRA. How are you gents doing today? We'll start with you, Jim.
I'm doing very well. Thank you very much for having us.
Sure thing. And you, Jay?
Great. Thanks, Brandon.
Sure thing. So, Jim, it is apparent today that security is an issue not only for connected devices, we all know about the Internet of Things and security issues there, but also just a range of other devices, any electronic system today. And that has become a problem because traditionally there haven't been security workflows built into the development lifecycle. Maybe you could automate things to the point where they're way too high level or way too low level. You're getting dinged every other line that there's some potential issue here. How is that being addressed through LDRA's offerings?
Yeah, it's a good question and a good problem. It really depends on your level of maturity of analyzing your code and your development process as a whole. From an automation perspective, where a lot of our customers start is in the area of static analysis, and that's being able to automatically analyze your code for security vulnerabilities or any defects that may exist in that code. That's typically a first step in the automation process. Then from an automation perspective, we help them on the dynamic side of things to analyze their code once it's executing during runtime for any particular problems. In fact, Jay's going to give you a little bit of a demonstration more focused on the static analysis side. In the static analysis area, we take a look more specifically at the complexity of the code or coding standards that may be employed in the organization. Coding standards such as MISRA and CERT-C are very common in the security area now. And actually, Jay will give you a demonstration how we employ our coding standards compliance automation tools to analyze that code for any security vulnerabilities that may exist there.
Very good. Well, do you think it's time to pass the baton over to Jay?
Yeah, definitely. Jay, please.
So where I like to start is I like to start from the standard. So, the place that I'm starting from is I went to the CERT-C coding standard, and this is all available on the web. And I'm going to highlight some of the rules in the CERT-C programming standard. If I go to the top, I can get the entire rule list, and then I can click through to, I'll just look at one of these, declare objects with appropriate storage duration. And it's a good one to look at because the severity is high, the remediation cost is high, and the likelihood is probable. We've all done this. So if I click into the particulars of the standard, I see some examples such as this, where we have this, this variable, this will change, that's associated with this function, but in the process of the function passes it into a pointer of greater scope. So this variable is out of scope by the time it gets to a function that prints it. And in C and C++, these types of vulnerabilities are common. Obviously, if you're using languages with garbage collections such as Java, you're not that used to this, but these are some of the common causes of C and C++ security vulnerabilities. And they're important from a safety and a security point of view, because from a safety point of view, if your code stops, well, maybe your vehicle or your airplane stops, so that's not good. But also, if your code allows an intruder to insert data into a buffer, well, that can allow them to take control of the vehicle or the device. And that's why these vulnerabilities are really important from both points of view. And I'll show you how they fit in both of those. So I'm going to show you this example, and then another similar example here, where we talk about, again, a local array that's being passed to a pointer. In this case, it's coming through to a parameter. And I'm going to use this example to just highlight the added value of dynamic analysis as well. So are you ready to see what we can do, Brandon? So the CERT team put together these examples, and I'm gonna pull them into LDRA. DCL30, so that's the name of the rule in the CERT standard. And I'll go ahead and right click and do View Code Review, and I can see that violation appear here, and I can double click on the violation to see exactly where it occurs. Again, it's all about that pointer being cast to the wider scope, where I have that global variable that's being passed to effectively a local variable. And I can click through to get more information. For instance, I can click on what we call the phase code, but this is basically the detailed information in LDRA. And I'll go ahead and pick the particulars. And this is a detailed example that highlights exactly what to do wrong, and also highlights all the different standards that call it out. This one I highlighted because it occurs in many standards. It's called out in CERT-C and MISRA and AUTOSAR and just about everything else because you know, the severity of this particular problem is high. So I can see exactly how it's called out in CERT-C. I mentioned the rule is DCL 30. So if I go to the details about the standard, I can see the rule is all about declaring objects with the appropriate storage duration. And then I can go back to LDRA and say, hey, well, how does this relate to MISRA? And I can apply my MISRA C 2012 standard and view code review. And I can see, hey, the same problem is part of MISRA, except in MISRA, it's R18.6, and it's still about that pointer assignment to a wider scope. And I can double click on and get to the text of the MISRA standard. And I can see that MISRA also finds it very important to manage the scope of variables. So the same issues are present in CERT-C and in MISRA because again, they're important from both a safety and a security point of view. MISRA,
and as you showed, Jay, you know, within LDRA, I think you mentioned this as well. We're not just looking in the context, able to look in the context of CERT-C and MISRA-C. There are a bunch of other standards that you can be referencing and checking against, as we see here, right?
Yeah, that's true. And in reality, most people will make their own standard because, especially today, you're going to want. I mean, there's kind of three things that drive it. I mean, one is what's the underlying process? Is it a road vehicle, an airplane, or a device? And then two is what are the security requirements? What are the safety? And three is what are the safety requirements? So you really want to get to that the circle of that Venn diagram where you have your vehicle or your device specific requirements and safety and security. You want to make sure you're tracking all of your requirements there. So I wanted to show another example. And in this example, I'm going to also show how dynamic analysis fits into the process. And I can go ahead and close these, and then I'll view my code review report. And I can see, in this case, again, remember, we're talking about that DCL 30, so I see that DCL 30. I can click to see the violation. I, again, have a pointer, and I'm doing something with the pointer, assigning it to a wider scope. But there may be some other issues that dynamic analysis highlights that are really interesting from a user point of view. So what I'm going to do is I'm going to load this into our unit test tool and then automatically create a set of unit tests to do effectively fuzz testing. Put in some inputs and outputs, not what the developer expected, not what the code expected, and see what happens. So I'll go ahead and jump into that. I'll launch TB run, and then TB run. I'll go ahead create a sequence. A sequence is a container for test cases, and I always do a test build. I just make sure everything compiles. It's just out of habit for me. But then I can go ahead and right-click and do run standard extreme test. And the tool has automatically created a couple test cases. And the first one says suspended, and the second one says pass. So remember, this pass is regression path. It means that we're getting the same results. And in this context, suspended means, well, we don't, it is actually failing in the process of executing. And then if I look at why it's failing, it's all about what the inputs and outputs are. Here I have a pointer parameter that's assigned to a local variable, and it's not assigned to anything. So then when I go into the code and I dereference that pointer, well, I'm dereferencing a null pointer, and then I have another problem. So in this case, dynamic analysis, and specifically automated unit test, allows me to pick out this case. Well, maybe I should have checked this for null before dereferencing it. In a very quick way that allows you to highlight these kinds of failures before they happen in the field.
Jim, back to you. What are we looking at in terms of the tools that are available from LDRA, how they work together, how a developer would transition from doing static analysis to dynamic analysis, and when, et cetera, how all of this could be put into a secure workflow?
In terms of adoption, it depends on the industry and the company's level of maturity. The reality of the matter is it's all over the map in terms of where people start. Most of them do start in static analysis because they get very quick feedback. That's one of the things that you actually saw from Jay's demo, is that they get real quick feedback about the quality of their code from a security perspective and a functional safety perspective. Their intended behavior of the code, if you will. From an automation standpoint, as maturity grows, they'll move from static analysis into more dynamic analysis, automatically generating test cases, and then linking all of these things together, their security and functional safety requirements, to their static analysis process, to their dynamic testing and unit testing process, where they can link from a requirement all the way down into the code and the tests and the test results. And so you have this bi-directional traceability of their entire software development workflow, which is really important for particularly the more demanding audiences, those that have to adhere to a particular set of standards.
I was just going to point out, as you did, that a lot of developers are probably wiping their brow, saying, "Wow, at least we have some level of automation here that can help us with these, frankly, daunting and damn near impossible tasks of checking all of this code to make sure that it's robust from a security standpoint." And all of that's happening sort of in tandem with this move towards what we were talking about a little bit earlier off air of DevSecOps, of continuous integration,
right,
which is in and of itself a brave new world. So how do you see LDRA's tools being integrated within that that evolution to a new type of development in industries that are still doing things the old-fashioned way?
Yeah, well, first of all, companies can't afford to do it the old-fashioned way anymore. That's the reality. If they want to be competitive in the market, they have to automate. And the automation, which some of what you saw today, really helps them save the time and money and helping them improve their security and safety of the software that they're developing to put in these critical systems. Also, in reality, again, is that a lot of our customers are moving to DevSecOps, and with respect to continuous integration and continuous delivery, they're really starting to unify their development process with their security requirements and their overall operation. So from a systems perspective, they're covering from requirements through verification in a much more automated way. So they need to really develop and deliver secure and functionally safe software faster. And they do that through automation, the monitoring that's now available through the tool suite, and what we offer in our customers throughout the software development lifecycle. So testing and security are really shifting left, if you will. And from an automated perspective, we're talking about unit, functional integration, security testing. These things are really being pulled much earlier into the development process to help them improve their overall quality of their code and the robustness of their code.